Hello students, Miss Slyman here with another example that I quite like. So I look at this and I might first think about substitution, letting this be my u and thinking that together the secant x dx will be my du, except that I know that the derivative of tan is secant squared and derivative of cos is negative sine, so those two things together definitely don't make my secant x. So instead I'm going to expand this. I know that secant is the same as 1 over cos. So when I expand 1 over cos times tan, that's going to be sine x over cos squared x dx, plus 1 over cos times cos is integral of 1 dx. And now this I could definitely do a u substitution. If we let u be our cos x, then the derivative, du dx, derivative of cos is negative sine, and I'm moving the dx to the other side. Of course, the negative I'll move to the other side because I've got sine dx, so I'll end up with negative integral 1 over u squared du, plus integral of 1 dx is just x. I'll go ahead and add my constant now so I don't forget it. So integral of negative 1 over u squared, well, I know that's the same as u to the negative 2. So I add 1, I get negative 1. Negative divided by negative 1 is positive 1. So I'm going to end up with 1 over u. But of course my u was cos x. So cos x plus c. And I'm going to rewrite that as secant x plus c as my final integral. Let's look at the last example. So we've got sine squared of 3x dx. You might first think u substitution, but normally I would let my u be 3x, and that doesn't help me because I don't know the integral of sine squared. So we've got this hint that cosine of 2u is 1 minus sine squared u. So if I think about this, then sine squared u is the same as cosine of 1 minus cos 2u divide by 2. All right, so if I think about letting my sine squared 3x, this I can rearrange as integral of 1 minus cosine of 2 times 3x, that's going to be 6x over 2. So these are equivalent statements, dx. I can separate it out. I'll have the integral of a half dx minus integral of a half. I can put that half in front. Cosine of 6x dx. And now I can let my u be 6x. Then du will just be 6 dx. So I've got a half dx, so I can see that 1/12 du is the same as a half dx. So I'll go ahead and substitute for my half dx. So I'll have integral of a half dx minus 1/12 integral of cos u du. Integral of a half dx, that's a half x, minus integral of cosine is sine, so 1/12 sine of 6x plus c. So two fun examples there.